Hey there, I just wanted to go over some of the topics to focus on for our upcoming Chapter 2 test. So some of the things that we've covered in Chapter 2 include domain of functions, so you should know how to find the domain of any function given. Evaluating and graphing piecewise functions. In graphing them, you need to evaluate them, so those kind of go hand in hand. Finding the average rate of a function in a numerical interval. So if I give you something like a function, find the rate of change in an interval, say 1 to 2. So that's what I mean by a numerical interval. Find the average rate of change of a function in an interval such as a and a plus h. So I could give you like 3 and 3 plus h. So where the h is a variable. Simplifying the difference quotient, which is really just the same thing as number 4 with x and x plus h. Also, you should know how to do operations with functions, adding them, subtracting them, multiplying them, dividing them, etc., and then compositions of functions, and finding domains for all of those. Inverses and how to know if a function is one-to-one, right? A function only has an inverse if the function is one-to-one. So if the function is not one-to-one, we can't really talk about the inverse of a function. And then the last two also go hand in hand. Finding the local maximum and minimum values of a function given a graph, and then also the intervals where a function is increasing or decreasing. So I'm going to do some examples of just some of the things that I've seen in work submitted, and just want to correct a few little issues. So for this first example, say we want to graph these piecewise function. And so some of you on quizzes, I already noticed that you can go directly to the graph. So I'm going to try to do that as well, go directly to the graph. So for this particular function, notice that our split point happens at x equals -1. So I'm going to plot -1 in our grid. And then, so to the left of -1, we look like the parabola x plus 2 squared. So this has a shift. So this is a horizontal shift to x equals -2. So let's graph what that would look like. So at -2, that's where our vertex moves to. So if you want to find the y-intercept of this, I guess we don't need it because it goes at x equals -1. So I would want to know what is the function value when x is -1. So when x is -1, I'm going to plug it into this function. So -1 plus 2 squared, which is just 1 squared, which is 1. So at -1, we're going to be up here at 1. And then our parabola. So to the best that you can, draw a parabola. I'm not doing a very good job here as usual with my tablet. And this is solid because it is included. Now when x is -1 for this one, so this is the line 2x minus 3. So we have a y-intercept at -3. And so we're going to cross there. When x is -1, so what does this guy do when x is -1? So when x is -1, we get 2 times -1 minus 3, which is -5. So that means that at -1, here we're going to go down to -5, and that's going to be an open circle because it's not included. And then we draw our line. And so this is the function. Now, to make sure that it is a function, remember, a function has to pass the vertical line test. So if I draw a vertical line anywhere here, it touches the graph only once. So that's why this one is solid and this one is open. So if I draw a vertical line here, it touches only once. So always when you draw a piecewise function, draw yourself vertical lines and see, do we touch only once? Yes. If you don't, that means you have graphed the wrong portions of the functions. Okay, so that's our first example. The next example that I want to do is something with simplifying the difference quotient, so number 5. So let's try simplifying the difference quotient for a particular function. Okay, so in this example, let f of x be 2x squared plus 1, and we're going to simplify the difference quotient. So the difference quotient is this quantity, f of x plus h minus f of x all over h, which is really the average rate of change on the interval x and x plus h. And so we're going to simplify that. What does it mean to simplify it? The goal for these is to eliminate the h from the bottom, from the denominator. So that is the goal when simplifying the difference quotient. I know that in some of the homeworks you had the square root, some of the radicals, and the radicals were in the numerator, but the goal for the difference quotient is to get rid of the h in the denominator. So it's okay to have radicals in the denominator because the goal here is to get rid of the h. All right, so let's try it. So f of x plus h is going to be, so you can do it in steps, find f of x plus h first. So f of x is 2x squared plus 1, so f of x plus h will be 2. Everywhere you see an h, you plug in x plus h. Or sorry, everywhere you see an x, you plug in x plus h. And multiply this out, right? X plus h squared, and be really careful here. X plus h squared is, you're doing x plus h times itself. So you have to FOIL. So it's x squared plus 2xh plus h squared. And then I have the plus 1. So that's f of x plus h. F of x is the original function, 2x squared plus 1. So let's put it together. So therefore, our difference quotient, f of x plus h minus f of x all over h, will look like f of x plus h. So that I'm going to distribute the 2 as I go. So it'll be 2x squared plus 4xh plus 2h squared plus 1, right? That plus 1. Now minus f of x. Since f of x has more than one term, what I'm going to do is put parentheses in there. And then the whole thing is divided by h. Now remember, our goal is to eliminate this h. And because it's in the denominator, so that means we're going to want to divide it with something. So let's combine like terms. Well, actually, let's distribute that negative. So I have 2x squared plus 4xh plus 2h squared plus 1 minus 2x squared, distributing this negative, minus 1. I like to make use of parentheses because, especially when there's a negative and a quantity following, if you're really good at doing it, just carry the negative as you go, then that's fine. But this is a very likely place to make mistakes. People will just put minus 2x squared plus 1 without the parentheses and then forget that that negative needs to be distributed to the plus 1 as well. Okay, so let's combine like terms. So I see a 2x squared minus 2x squared, so those actually zero out. Plus 1 and minus 1, those also subtract out to give us 0. So we're left with 4xh plus 2h squared all over h. So notice that in the top we have everything has an h, so we can factor it out. So 4x plus 2h all over h. And now I can achieve our goal. H divided by h is 1. Now we're dividing, so that gives us a 1 to cancel out. We're used to saying cancel out, but what's really happening is they're dividing out to be 1. So I'm left with 4x plus 2h, and that is the difference quotient simplified. We got rid of the h in the denominator, which is the goal. Okay, so for our next example, I want to do a composition of functions where we also find the domain of the composition. So let's say that I give you f of x is the function, the square root of x minus 11, and g of x is the function x squared plus 2. And say let's want to find the composition f circle g of x and find the domain. So that's our task. So let's see. This f circle g, that's the composition. That's the notation for composition of functions. which then we can write it as the more commonly used f of g of x, and find what this is. So this means that into f, this function, the square root, we're going to plug in g. So everywhere we see an x, we're going to plug in g. So this is going to look like the square root of g of x minus 11, right? So there's my f. So wherever I see an x, x is going to get replaced with g of x for the composition. And so now I have f of g of x equals, and now putting what g of x is. G of x is x squared plus 2. So this looks like x squared plus 2 minus 11, which is really the square root of x squared minus 9. Plus 2 minus 11 gives us minus 9. So that is our composition of functions. Now, how do we find the domain? So because we have a radical, we can say, well, we can't take the square root of a negative number, so we want the inside of that radical, so x squared minus 9, to be greater than or equal to 0. It's okay to be equal because the square root of 0 is 0, but then we want everything in here to be a positive number because we can't take the square root of a negative number. And so at this point, we're back to things that we did in chapter 1, where we want to solve this inequality. So it's a higher order inequality, nonlinear, so we have to factor first. So this factors into x minus 3x plus 3 greater than or equal to 0. And then we draw the number line, right? Don't do each one greater than or equal to 0 and then solve it that way. So what makes this 0? 3. And we will include it because we have the equals there. And what makes this one, x plus 3, 0? And x is negative 3. And we pick test points. So we have 3 intervals. We have from minus infinity to negative 3. Oops, that one is included. Negative 3 we get to include. Then we also have the interval negative 3 to 3 included. And we also have the interval 3 to infinity included at 3. So pick a test point. So we can pick let x be in this interval, say negative 4, and we're testing this product. We want the product to be positive. So negative 4 minus 3 times negative 4 plus 3. So what is this, positive or negative? So I have negative 7 times a negative 1, so negative times a negative is positive. Do we want that? Yes. So we're going to shade that. Something between negative 3 and 3. Be nice to yourself. Let x be 0. So when you plug in 0, you're going to have 0 minus 3, which is negative, and 0 plus 3, which is positive. So you have a negative times a positive, which is negative. So we don't want that. We want the product to be positive. And something larger than 3, let x be 10. I don't know, something random that's bigger than 3. So I'm going to have 10 minus 3 and 10 plus 3. Positive and positive gives us positive. So we do want that. So our domain is from minus infinity to negative 3 and from positive 3 to infinity. So on the test, I want to see your work on how did you arrive at that interval. So just giving me the interval is not going to be sufficient if it's not a multiple choice question. If it's multiple choice, then you select the proper answer. But if I'm asking you to show your work to submit a file, it's because I want to see your work and I want to see your process. So just giving the answer is not going to give you full credit. So the domain will be minus infinity to minus 3 union 3 to infinity. So that will be the domain, and this is my supporting work. Okay, and then from here, I think those are the main things that I have seen. Perhaps some small little issues and some algebra that I wanted to bring to the attention. For the domain and solving inequalities, the main thing is that I'm seeing is people going from x squared minus 9 greater than or equal to 0, going directly to the answer. And I want to see, if I'm asking you to submit a file for your work, I want to see your work. I want to see your process. That's what I'm giving you credit for. email me if you have any questions. And I will also encourage you to practice finding the inverse of a function for the chapter 2 test. All right.